I have posted over 200 videos, and it may be difficult to find a topic that you may be interested in. So I am posting a list of my playlists and the contents inside of each playlist. You will probably notice that the more advanced topics are at the top and the basic topics are at the bottom of the list. This is because I started posting the basic topics first and gradually moved on to the more advanced topics. YouTube makes it so that the latest posting will always be on top of the list. I tried changing the sequence, but it keeps coming back to this arrangement. So if you are looking for a certain topic, please check out this video to find the topic that you are looking for. In my opinion, these are the proper sequence to learn or to study the math basics. So first you need to learn the addition, subtraction, multiplication, and division of whole numbers. And then fractions, and then decimals. Next, you need to learn the conversion between fractions, decimals, and percent. And then third, you need to know addition, subtraction, multiplication, and division of integers, which are the positive and negative whole numbers. And then positive and negative fractions, and positive and negative decimals. So the fourth one is you need to learn about exponents. The fifth one, radicals. And number 6, variables, from the most basic to the most advanced. Once you learn these math basics, it will be easier to learn the other branches of math. I will be displaying the playlist from the most basic up to the most advanced. So I will be discussing the playlist starting from the bottom of the list and going up. So the first playlist will be whole numbers, memorizing the multiplication table, rounding off numbers. So the topics under that playlist will be addition of large numbers, subtraction of large numbers, multiplication of large numbers, division of large numbers, how to memorize the multiplication table the easiest way, rounding off numbers, and how to memorize table 9 the easiest way. These are shorts. The next playlist is fractions, decimals, percent, exponents, and radicals. Now, fraction is a very large topic, so I divided it into 5 parts. So these first topics are fractions from parts 1 to part 5. After that is the next 2 topics is like a summary. So it's called fraction fundamentals, part 1 and 2. So they are just a summary of the first 5 topics. After the fractions are decimals, so there's addition and subtraction, and then decimals, multiplication, and division. After decimals is percent, so it will be discussing percent, how to solve word problems regarding percent. After that is the conversion between percent, decimal, and fraction. After the conversion is exponents, and then radicals with numbers. Next one is rationalizing the denominator. This topic is under radicals. After this, rationalizing the denominators, the following topics are just shorts. That is taken from the first few topics of fractions, decimals, and percent. The first 2 playlists that I have just recently discussed involved only positive numbers, positive fractions, and positive decimals. Now for this topic, this third playlist, it includes the negative parts. So it's about integers, which is the positive and negative numbers, and then negative and positive decimals, negative and positive fractions, variables, and then some conversions, perimeters, volumes, areas, and surface areas. So the first topic is integers, addition and subtraction. So I've divided it into two parts because it's a large topic. And then fractions, that are both positive and negative fractions, are divided into addition, subtraction, and then multiplication, division. And then I summarize it in this next topic: negative decimals, addition, subtraction, multiplication, and division. Now variables are also a large topic, so I divide it into 4 parts. So variables, parts 1 to part 4. After that is the conversion of dimensions from one unit to another using dimensional analysis. So I'm introducing dimensional analysis here. This is a good method to use and make it easier and to avoid errors. Next one is perimeter, how to compute perimeter. And then next is compute for areas, parts 1 to up to part 3, because it's also a large topic. I divide it into 3 parts. Next is the difference between volume and surface area. After that is the volume, how to compute volume. Next is how to compute surface area. And then the next topics are just mostly shorts that are taken from the initial topics from here. The next playlist is about word problems, Cartesian coordinates, integers, and negative decimals. So first is the word problems using dimensional analysis. Dimensional analysis is the inclusion of all the units in the variables and all the data, and it will make it easier to solve and lessen errors, and to make sure that the units are compatible or are the same. Next is word problems in percent. Next is word problems with chemical solutions. Next one is how to derive a formula. And next is work problems and tank problems examples. Work problems and tank problems are similar in nature. Next is age problems. Next one is ratio and proportion word problems. And then ratio and proportion similar triangles. Now the next 3 topics are from physics, but they are all actually ratio and proportion. So these are Gay-Lussac's law, Avogadro's law, and Boyle's law. After these are percent word problems. And next is how to plot points in a Cartesian coordinate system. Next is how to get the distance between 2 points. Next is how to graph a linear equation by plotting points, and then by slope intercept form, and then a combination of the two. The next playlist is about tips and tricks to excel in math. So the first topic, I have made 6 books in math that are now available for a price, and it starts from the very basic up to Cartesian coordinates, and more books to follow soon. Next topic is why is math different from all the other subjects. Math, to study math is different from all the rest of the subjects. There's a different method of studying math. Next is how to memorize table 9. The easiest way, but because there's a trick to memorize table 9, and quick and easy. So next is some people think there's a mystery or witchcraft or black magic in math, but actually math is all just made out of logic, from logic. Next is how to excel in math, some personal things that I've discovered to how to excel. Next is how to memorize the whole multiplication table from table 1 to table 10. And actually, it's not as hard as you think it is. You don't need to memorize all the tables. You only need to memorize from 6 to 9, table 6 to table 9. Next is how to have a perfect score in math every time. So there's a way to have a perfect score. So I personally attest to this. If I want a perfect score, this is what I do. How to add fractions the easiest and fastest way. There are now, I'm sure I have done some ways to make it easier to add fractions. And next is to subtract fractions, which is similar in principle. Next is math secrets you should know about. So there are some secrets that actually more only if you learn math, then you will learn of these secrets. Next is proven techniques to increase your score in math exams. So sometimes you just want to increase your score. These are the tips that you want to follow. Next is memorize the multiplication table the easiest way. So these are a longer version of the first topic. How to use Math Made Easy books. So in case you want to you're interested in buying, this is how you use it. The previous one is number sequence. How to solve number sequence. There's a method of making it easier. Next is abstract reasoning. I just want to introduce abstract reasoning because technically this is also a part of the math exams in some of the exams that I've taken. Next is math trick for quadratic equations. So there's a way to solve quadratic equations, solving for x. And then the next one is solving for x in quadratic equations. This is like a modified technique and making it much easier to solve quadratic equations. And next is how I became good at math. There was a story here how I became good at math. Next is Pythagorean triples. These are three numbers that are sides of a triangle that will make a right triangle. Next is spatial intelligence. Spatial as in space. It will help you to improve your talent in terms of space. Next is math trick number 1, estimating the products of large numbers. Sometimes you would need to compute to multiply large numbers and you don't have a calculator and you don't have enough time. This is a trick. This is a good trick. And next is a math exam review for job applicants. So if you're a job applicant and you'll be taking a math exam, this is a good topic to watch. The next playlist is about trigonometry. The first is the introduction to trigonometry. Trigonometry is basically about triangles and more specifically about right triangles. So it will give you a good idea about trigonometry. And next is trigonometric functions and the principles behind it. So these are the sine, cosine, tangent, and the important thing is what it is. And in this, the principles behind it will tell you how that can be used. Next is pi, degrees and radians. So this is the measure of angles, and the constant pi as regards to especially about circles. Next, the next three topics are just examples of trigonometric problems. So there's 1, 2, 3. Next is inverse trigonometric functions. So when you have the trigonometry is about ratios of sides. So if you have the ratio of the sides, you can get the angle of that side. So it's in inverse trigonometric functions. The next is sine law. So it will show you there's some problems that will require the sine law to compute for sides or angles of a triangle. Next is cosine law, similar to sine law. They'll help you to solve sides or angles of a triangle. Next is the polar coordinate system. And after that is the Cartesian coordinate system, and the conversion between polar coordinate system and Cartesian coordinate system. These two systems are it will show locations in a plane, in a two-dimensional plane, and they have different systems of locating points. And there's a conversion between the two. Next is a Heron's formula. So this is a condition where the three sides of the triangle are given, and you can compute for the angles. Now, Pythagorean triples are they are just same as before. Three numbers that of the sides of a triangle which will form a right triangle. Next is ratio and proportion or similar triangles. And next is Pythagorean theorem to solve right triangles. And now the next four, how many is this? 1, 2, 3, 4, 5, 6. So the next 6 topics are physics topics under the subject of physics, but they were using trigonometry to solve the problem. So I've included these 6 topics under trigonometry. The next is trigonometry sine function. So it's just discussing about sine. And there's a shorts, sine law in shorts, cosine law as a short version. Next is inverse trigonometric function, also a short version. Next is complex numbers or imaginary numbers. So this is under trigonometry, so I have included it here. And the last one is how to solve using special triangles. Special triangles are 30 by 60 by 90 and 45 by 45 by 90 degrees. Next playlist is physics. I have included some of the more common topics in physics. So first is combined gas law, next Avogadro's law, Gay-Lussac's law, Boyle's law, heat, energy, and specific capacity, force, work, power, and energy, linear expansion of solids, friction on an inclined plane, force acting diagonally on an object with friction, force and acceleration, vector addition, projectile motion, object released at an angle, resolution of a vector and finding the resultant vector, resolution of vector into its vertical and horizontal components, difference between scalar quantity and vector quantity, free fall with horizontal velocity, acceleration due to gravity formulas, acceleration due to gravity, find the height of the building, acceleration and velocity formulas, how to solve for velocity, and difference between speed and velocity. Next playlist is geometry. I did not include proving theorems and postulates, because that would be your usual topics in your school. But these topics that I have posted are more on the application of the theorems and postulates. So these are problem sets that will be using geometry to solve for angles and lines. This also includes perimeters, areas, and volume, and surface area. The last topic, spatial intelligence, is about space. So it's a different part, but still part of the geometry. Next topic is conic sections. So these are basically precalculus, but I separated it, make it easier to look for. Actually, these conic sections are part of analytic geometry. So we got hyperbola with center at HK and then at origin, ellipse with center at HK and then at origin, parabola with vertex at HK and at the origin, the equation of a circle, and then lines and conic sections. I have only 2 topics on the playlist of statistics and overview, and statistics summary. I only have posted 2 because there's not many students or other people watching it, so I'm assuming it's not a difficult subject. But I can post more if some would be requesting for it. The next playlist is algebra. Algebra is a very broad topic, and so these topics that I have posted are from different areas. So there's H problems explained in detail, points of intersection between lines and curves, solving for 2 variables by addition of equations or by elimination, substitution method to solve for 2 variables, complex numbers, imaginary numbers, rationalizing the denominator, solving for x in quadratic equations part 1, and math trick for quadratic equations part 2. How to get the distance between 2 points, 2-point form, slope-intercept method to determine parallel, non-parallel, and perpendicular lines, the slope of a line, probability of an event, non-repeating permutation, repeating permutation, circular permutation, permutation versus combination, factoring, the 4 most common factoring methods, factoring less common form, 2 equations and 2 unknowns, how to solve this, principles of solving for variables part 1, more complicated examples of variables part 2, 2 or more denominator in the equation, variables part 3, and then variables with decimals part 4. Precalculus, these are the topics that you would definitely need to master before studying calculus. So first is point of intersection between lines and curves, polar coordinates to Cartesian or rectangular coordinates, Cartesian to polar coordinates, solving for x in quadratic equations part 1, matrix for quadratic equations part 2, hyperbola with center at origin, hyperbola with center at HK, ellipse with center at origin, ellipse with center at HK, parabola with vertex at origin, and parabola with vertex at HK. Next is finding the equation of a circle. Next is lines and conic sections. Then 2-point form, and then 2-point form examples. Example, point slope form, slope-intercept method for determining parallel, non-parallel, and perpendicular lines. Draw a line with a given point and slope, the slope of a line, factoring, the 4 most common factoring methods, factoring less common forms, factoring to simplify polynomial shorts. How to graph a linear equation by plotting points and slope-intercept method, graph a linear equation by slope-intercept form, graph a linear equation by plotting points, how to get the distance between 2 points, how to get the distance between 2 points to principal, plot points in a Cartesian coordinate system, compute for areas parts 1 to 3. Last but definitely not the least is calculus. I think it would be ideal to study calculus in the sequence that I have posted here, starting from calculus 1 from the top up to the bottom. And this is the way I posted it, and this should be the best way to learn calculus, from the simplest to the most advanced. So calculus 1, limits or introduction to calculus. Calculus 2, the derivative or difference quotient. Calculus 3, the power rule, a derivation shortcut. Calculus 4, maxima and minima. And then there's differential calculus, the derivative, summarized and explained. So this is a summary of calculus 1 to 4. Differential calculus, finding the slope of the curve, is just one example. Integral calculus 1, finding the area under the curve. So this is the first of the integral calculus. Then y area is equal to its integral shorts. And then integral calculus, finding the area. Next is finding points of intersection between lines and curves. Finding areas between two curves or lines by integration. Integration with respect to the y-axis. And then finding the volume by integration using the disk or washer method. And then I will be adding some more on every playlist, and I will be updating this playlist and its contents